So in this video today, guys, we're going to talk about how to fit data to a normal distribution. So first thing is we want to talk about what is a normal distribution. So it's a probability distribution that can be modeled by a bell-shaped curve that's symmetric about the mean. So the mean will be here in the middle, okay? So it's going to be symmetric about this point right here, okay? So then the bell-shaped curve is what we call a normal curve, and normal curves are used in a wide variety of situations to estimate probabilities. So the total area underneath this whole curve is 100%. So if we were to add up all these percentages, they would add up to be 100%. So that's your first blank in your notes. Now, for normally distributed data, the empirical rule tells us that approximately 68% of the data lie within one standard deviation of the mean. Okay, so that means that 68% of our data is right here, guys. Okay, well, I didn't do that very good. Let me try that again. So 68% of our data is going to be right there, right? Because why? 34 plus 34 is 68. Then 95% of our data is going to lie within two standard deviations of the mean. So if we were to look at all the data from here, that's two standard deviations away, and this is two standard deviations away. So now that's going to actually be 95% of our data. And that would be like a shaded area under the curve, okay? And then the last one is going to be three standard deviations, okay? So once we get to three standard deviations, that's out here. We're now at 99.7% of our data. That was not very pretty, but it's okay. 99.7% of our data. And that's because we only have 0.15 and 0.15 left outside of three standard deviations away from the mean. Okay, so as we work through these problems today, we're going to use these values. And you guys have this on your formula sheet that we gave you guys, okay? So first of all, it says a normal distribution has a mean of, that's our x over with a line over it, right? That can also be written as mu, okay? So that mu, see that's this mu down here? That's another symbol for standard deviation. So I kind of like to put just the x with a line over the top of it there so that we can see that we're going to actually take our standard deviation and we're going to take our mean and we're going to add one standard deviation to it to get the value here, and then 2 and then 3, right? And then as we move to the left, same thing, okay? So now what we're going to do first is we're just going to use the standard curve with the percentages to find the indicated probability for randomly selected x values from the distribution. So let's look at this first thing. So what is the probability when x is less than mu plus 1 standard deviation, okay? So that means we're looking at this data right here, right? So, and it's saying less than. So we want all the data that's to the left of that, right? So that means we're going to add all those numbers together. 0.15 plus 2.35 plus our 13.5. Y'all see what I'm doing? I'm taking this data right here and adding them together. Plus 34 plus 34, okay? So now you can get quicker with this as you work through it because you're going to know, obviously, that this is half the graph too. So we could have said that that's 50 plus our 34, and that would have gotten us 84%, right? So that's another way to do it. So that's 0.84. And the problem, the answers could be written either as percentages or as decimals. So you got to keep that in mind as well. All right, now let's look at number 2. So this one is that x now is greater than mu plus sigma, okay? So that this time we're looking at this one. We're going from here and getting bigger, right? So then we're going to add up those three numbers that are left there. So we got 13.5 plus 2.35 plus 0.15. And this is the opposite of the other ones. This is 16%, guys, which would be 0.16, okay? These are both equal to each other, okay? So we're just writing it as a decimal and as a percentage. All right, our third one. So let me erase this again. This time, we're between mu and mu plus sigma, okay? So this is mu right here, and mu plus sigma is right there. So that's just a straight up 34%. We can see that one pretty easy, right? And that's equal to 0.34, okay? Hopefully there's no questions on that. So now what I'd like you guys to do is do the U-tries, the next 3, and then come back to me when you're done. Okay, so this one says, again, less than mu minus 3 sigma. So this first one is going to be over here, right? So it's going to be that. So this is just going to be 0.15%, which again, if we were to write that as a decimal, it's going to be 0.0015, right? 2 places to the what? Left. Okay, so now let's look at our middle one. So this one is, oh, you know what? I should have told you I was C. This was mu minus sigma, okay? Just 1 sigma, okay? That's what that should have been. So B is x is greater than or equal to mu minus sigma. So this time we're going to the right, correct? So we've got mu minus sigma is here, and we're going all those data points to the right. So pretty sure this is going to be another 84%, isn't it? Because it's basically just the opposite of what we did initially. Okay, so this is 84%. And again, if you're not sure, then just set them, add them all together, right? That's all you have to do. So you're going to add 34 plus 34 plus 13.5 plus 2.35 plus 0.15, okay? All right, our last one is we're going to do between mu minus 1, that's here, and mu plus 2 sigma, so that's there. So we've got our 34 plus 34, which would be 68, right? Plus our 13.5. So I'm pretty sure this one's 81.5, which is equal percent, which is equal to 0.815 if we were to put it as a decimal. All right, so our next set of problems, we are now going to create our bell curve, okay? Well, we're not going to create the bell curve, but we're going to fill in our blanks down here. We're mu and mu plus sigma and mu plus 2 sigma and all of that, okay? So this one says the height and feet of a grown white oak tree are normally distributed about the mean. So I would put this on your original bell curve, y'all. So just use the one that's above, okay? All the way up there at the top. So our middle number here is going to be 90, right? Then we're going to add 3.5 to that. So it's going to be 93.5. Going to add 3.5 again. That's going to give us 97. And then we're going to get 100.5 there. Now to go left, we're going to subtract 3.5. Okay, so this is going to be 86.5. Subtract 3.5 again. That's going to be 83. Subtract 3.5 again. That's going to be 79.5. Okay. Now we're going to answer our questions, and these are all empirical rule questions, okay? So it says about what percentage of white oak trees have heights between the 86.5 and the 93.5. So between here and there. So isn't that going to be 68% because it's 34 plus 34. So that's 68%, which again is equal to 0.68. All right, then it says well, about what percent of white oak trees have a height less than 97 feet. Okay, so this one, we're going to go 97 to here, and we're going all the way that way, okay? Now, I want to give you all a hint again. This right here, from here down, is 50%. So we could say 50 plus what? 34 plus our 13.5. That's a quicker way to do it, because half of the curve is 50%. Okay, so when we add those three numbers together, I'm trying to find my paper, y'all. Sorry. That's 97.5%, okay? 97.5%, and that's equal to 0.975 if it's as a decimal. All right, our next one is going to be about what percentage of white oak trees have a height between. Okay, so this time we've got our 83 right here and our 90 right there. So this time the only two we're adding together is our 13.5 plus our 34. So when we add those together, we're going to get 47.5%. And again, that's equal to 0.475 if you were to write it both ways. Okay, now this last one says 95% of the data falls between which two values, okay? So if you recall, this was 68%, right? Our next one was what? This was 95% of our data because the next one was 99.7%, okay? So what did we get then? Wasn't that between 83 and 97? It was indeed. So that was the answer D right there, okay? All right, so let's see if you guys can do this. You try, and then come back to me when you're done, okay? So again, we're going to work this out. I'm going to put in the middle here my mean. So this says the mean batting score was 250. So we're going to add 20 to all the numbers on the right. So this is 270, 290, 310. And then for the left side, we're going to subtract, right? So we're going to get 230, 210, and then what? 190, okay? So you guys have your formula sheet. So this is going to be 34% and 34%, 13.5 and 13.5. And again, 2.35 and 0.15, 2.35 and 0.15, okay? So I kind of like to draw it, guys. You don't have to, but I really like to because it helps me visually. It says, what is the probability of a team having an average over 290? Okay, so if it's over 290, here's our 290, right? And we're going right from there. So what are we going to add together? The 2.35 plus the 0.15. So that's going to be 2.5%, which is equal to 0.025 if it's as a decimal. Then it says what percent of Braves players fall between 210 and 270. So here we've got 210 there and 270 there. So we're going to do the 13.5 plus the 68. Remember, 34 plus 34, 68. And that's going to be equal to 81.5%. And again, that's 0.815 if we write it as a decimal. Then the next one is what percent of Braves players have a batting average of at most 230. Okay, that's written a little bit different, right? So this time we're in an at most. So at most 230, that means this is my biggest number and everything else is below that, right? So we're going to say 13.5 plus 2.35 plus the 0.15. You add up those three numbers, you get 16%. And that's going to be written as 0.16. All right, then it says 68% of the data falls between which two values. Okay, so there we go. So there's our 68% right there, right? So that's 230 and 270. That was the answer to that one, okay? So on our next problem, it says the area under the curve between two x values corresponds to the probability that x is between those values. So the probability or area under the curve can be estimated using a table, but we're going to use it finding our calculators, okay? So scores on a test are normally distributed with a mean of 75, so that would be right here, right? That's where our 75 would be. And it looks to me, based on this, it says with a standard deviation of 8, right? So that means if we kept moving here by 8, that would be like 83. And then another 8 would be 91. But the value they're asking us to find is estimate the probability that a randomly selected student scored less than 87, okay? So that means this value is going to be in here somewhere, right? 87. And what we're really trying to find is the area under this curve, okay? So that means all of this would be shaded in. And that's what we're trying to find is all of this right here. Y'all got me? That's what we're trying to find is the area underneath that curve right there, okay? So to do this, we're then going to actually take these values that we just got, and we're going to put them in our calculator. So when we are trying to find all the values to the left of something, then we're going to talk about a lower bound and upper bound, a mean in the standard deviation. So whether we go lower bound really small number or upper bound really big number, will depend on what it's asking for. So we're going to put negative 1 million here. 6, yeah, there's 6. No, there's 6 there. Okay, and then our upper bound is going to be our 87 because that's the highest data point. Our mean was 75 and our standard deviation was 8. So we are going to actually put these in the calculator and it's actually going to find all this area under the curve for us, okay? So pause and let me go there. So here's the rub with this one, y'all. We can't do this one with the 30, but you can do it in Desmos. So if you guys are doing this for at home, and you can do it in the TI-84, and obviously you'll have the TI-84 when you take the test, okay? So let me show you here. So what we're going to go now is we're going to say second vars, and we want this normal CDF right here. That's the one we want. So we're going to click down to 2 and push enter. Now that already is a really small number, but just for, again, for the sake of our purposes, we're going to put negative. So click on your negative down here, and then 1 million. 1, 2, 3, 4, 5, 6, okay? So for our next value we had, our upper bound was 87. Then our next value was our mean, right? So that was 75. And then our next value was our standard deviation, and that was 8. So then once we put those in there, then we're going to actually click. Now, this is always going to be this way. Lower bound, upper bound, standard deviation, mean and standard deviation. Okay, then we're going to click enter again. It's going to give us the value. So it's 93.32% or 0.9332. Okay? So over on Desmos, what we want to do is click the function button. Okay, I'm actually going to close this out so I can show you guys where to find this. We're going to scroll down here to, again, normal distribution right there under distributions. And we're going to click this because that's what's going to give us our min and our max, okay? So when we do this, we're going to put our mean in this one, which was 75, if you remember. And then we're going to put, comma, we're going to put, yes, our 8, which are standard deviation. Then our minimum, notice they had negative infinity there, but we're just going to keep our negative 1 million, right? That's going to be our minimum. And then our maximum, we had 87, right? So there it is, same answer, okay? So again, go under functions, under normal distribution, make sure you click this find cumulative probability because that's how you're going to be able to put in your min and your max, okay? Okay, so now this letter B is going to be similar to what we just did, but it said a score higher than 80. So now the two that are going to always stay the same when we have the same problem, y'all, are our mean and our standard deviation. So now we got to find our lower bound, which this time is going to be what? 80, right? And our upper bound is going to be a really big number because we are looking at a number, everything in this one is going to be bigger than 80, right? So we're going to go back over here to our TI-84. We're going to go to second vars, right? Our normal distribution here and click enter. Now the good thing is here, we don't have to change except for lower and upper, right? So we're going to clear this number and we're going to put this time for our lower bound 80. Right? And then for our upper bound, we're going to put a really big number. So we're going to put our 1 million, right? Or just some really big number. And click enter, enter, enter again. And one more time. And this one is 26.6%, right? Okay? So let's click back here. So this one is going to be our 26.6%. Right? Okay? Oh, I never wrote this one up here, y'all. It was 0.9332, which was equal to 93.32%, right? Okay? All right, let's do this last one. Now, this one, in my opinion, is the easiest because we don't have to figure anything out. We know our lower bound is going to be 71 and our upper bound is going to be 75. So we are going to, again, go second vars, go down to number 2, enter. So see our 75 and our 8 are still there. So all we have to do is put up here 71 was our lower bound and our upper bound was what? 75, right? Isn't that what the problem said? So here again, we're going to click enter, enter, enter. There's our values. And yep, it's 19.15%. Okay? So we're going to go back here. Full screen. So this answer was 0.1915, which is equal to 19.15%.